Hi, I'm Gabe. For this problem, we're asked to approximate the limit as x approaches infinity for this function here. And the way we're going to do this is by filling in some values in this table, and hopefully what we notice is that as the x values increase, our function values will get closer to a single number. So let's go ahead and get started by substituting 10 to the 0, or just 1, into our function. So what we see when we do that is that our function value is approximately negative 0.732. So continuing along, let's substitute in 10 to the first, or just 10, into our function. And what we see here is our function value is approximately negative 0.100. 10 squared, or 100. When we substitute that into our function, will give us approximately negative 0.010. Now as we move on to 10 cubed, or 1000, our function value will be approximately 10 to the negative 3. As we move on to 10 to the fourth, our function value will be approximately negative 10 to the negative fourth. 10 to the fifth, when we substitute this into our function, will give us approximately negative 10 to the negative fifth. And 10 to the sixth will give us a function value of approximately negative 10 to the negative sixth. So what we see here is that as these x values keep increasing from 1 to 10 to 100 and so on, our function values keep increasing to 0. So they start at negative 0.732 and they end up approximately negative 10 to the negative 6. So a relatively small negative number. So we can actually verify that the function values are approaching 0 by looking at the graph of this expression, or of this function. So let's go ahead and let's actually graph this function. And we'll want to make sure that our window is set appropriately. So let's go ahead and let's make our maximum x value something rather large. So here we went to 1,000,000. You could take it past that, let's say 1,000,000,000. And now when you graph your function, you see that the function approaches the x-axis, so the function values are getting closer to 0, and you can verify this by using the trace feature of your graphing utility. So now what we can say is that as these x values keep increasing, well, the function values are going to keep getting closer and closer to 0. So what we can say is that the limit as the function approaches infinity is 0. And just something to point out before we wrap up is that if we're looking at this function here, well, as the x values keep getting larger and larger and larger, this 2 right here almost becomes insignificant. So if you imagine just blocking out this 2, what you would have is x minus the square root of x squared, which is just x minus x, which is 0. Thank you.